What if I told you there are products that are built for one single purpose: to be destroyed the very first time they're used? Strange as it sounds, clay targets, better known as clay pigeons, fall into that category. These small, brightly colored discs are designed to be launched at high speeds, fly gracefully through the air, and then shatter the moment they're struck by a pellet. But have you ever stopped to wonder how they're made? What goes into creating something so precise, yet so fragile? In today's video, we're going behind the scenes of clay target production to see how they're engineered to fly, survive the launch, and break apart at just the right moment. The surprising materials behind clay targets. Despite the name, clay pigeons aren't made from clay at all. Instead, the main ingredients are petroleum pitch and calcium carbonate, commonly known as talc. Petroleum pitch is a sticky byproduct of crude oil that acts as a binder, holding everything together. Calcium carbonate, talc, is used as a filler that gives the target strength and structure while keeping it brittle enough to break on impact. This combination creates a material that's both tough and fragile, strong enough to withstand being hurled into the air at incredible speeds, but weak enough to explode into pieces when hit. Step 1. Preparing the ingredients. The production process starts with the arrival of calcium carbonate at the factory. It's stored in a heated silo to prevent it from clumping. From there, a screw conveyor transports it into a mixing tank. At the same time, petroleum pitch is kept in its own silo, heated to nearly 400 degrees Fahrenheit, so it stays in liquid form. Once ready, the two ingredients meet in the mixing tank. Here, about 22 pounds of pitch and 64 pounds of talc are blended together every 10 seconds, creating a hot, paste-like mixture. Step 2. Keeping the mixture stable. Because this mixture cools and hardens quickly, it needs to be reheated before shaping. The factory uses a system of oil pipes circulating at over 500 degrees Fahrenheit to maintain the perfect consistency. Without this reheating system, the paste would solidify too early, making it impossible to mold into targets. Step 3. Molding the targets. Once reheated, the molten paste flows into automated molding machines. These machines inject the material into disc-shaped molds, compressing them under pressure to give the targets their round shape. Cooling water circulates around the molds, solidifying the discs just enough so they can hold their form. A robotic transfer device then lifts each newly formed target and places it gently onto a conveyor belt. At this point, the clay targets are still warm and slightly flexible. They must continue cooling as they move down the line before they're ready for finishing. Step 4. Adding color and visibility. A clay target wouldn't be much use if shooters couldn't see it in the sky. That's why the next step is painting. The factory uses a paint mixture made from carbonate, powdered pigments, water, and binding agents. The discs are placed on spinning holders and sprayed evenly inside a special paint chamber. The bright, fluorescent orange or neon colors make the target stand out against the sky, ensuring shooters can track them easily. After painting, the discs move through a hot air drying tunnel where they're hardened and ready for the next step, all in just 30 seconds. Step 5. Stacking and packaging. Once painted and dried, the finished targets are carried by conveyor to an automated stacking machine. This machine neatly piles the discs into columns and prepares them for packaging. Depending on their final use, targets come in different sizes. The Olympic standard size is about 4 inches across, while smaller versions are made for training and recreational shooting. Some factories also produce special biodegradable versions designed to break down naturally after use, making them safer for the environment. Engineering the perfect break. The real genius of clay targets lies in their design. Each one is carefully engineered to do 3 things. 1. Fly straight and smooth when launched. 2. Hold its form in the air, resisting vibrations and spin. 3. Shatter dramatically on impact, giving shooters a clear sign they've made a hit. This balance of strength and fragility is why the production process is so precise. Too strong, and the target won't break. Too weak, and it will shatter before it's even launched. So the next time you see a clay pigeon explode into fragments mid-air, you'll know the fascinating process behind it. And if you enjoyed this video, don't forget to hit the like button, subscribe, and turn on the bell icon so you never miss our next videos.